Okay, so today we're going to be doing adding vectors. Just so you know that these vector questions are already complete. And I will be giving you a moment to pause at the beginning of each question to write everything down, and then I will be explaining each question as we go through it. I will be posting another video about cases 3 and 4 in which we calculate the resultant because they're a bit more complicated and need formulas. These are the formulas. So we have Pythagorean theorem, we have SOHCAHTOA, we have cosine law, and another cosine law, but with the angle. So you may need to review these before we get started. I'm sure you've seen them before, but we're going to be using them to solve our vector questions. And for solving the vector questions, the process is the same for each case. There are 4 cases in which we add vectors, and so here's the process. We have diagram, so we indicate what each vector problem looks like. We have calculate the resultant. So this varies from case to case, but follow proper procedure to find the resultant. It can be very easy or it can be very difficult. Calculate the direction of the resultant. So this could be in plain sight, in which you can do it goes east, or it goes north, or it goes northeast, or something similar to that. Or you have to use SOHCAHTOA or cosine law to find the angle. So you're going to be using this formula or SOHCAHTOA to find the angle. So it varies from problem to problem. But with each vector and resultant that we calculate, vectors have directions. So if you remember from our last video, they have both magnitude and direction. So when we calculate the resultant, we're going to need to include the direction. Magnitude meaning like 6 meters or 8 meters or 10 meters or however much the resultant is worth in value or in length or in distance. That's what magnitude means. And then we also have direction. So which way is it going? Is it going north, south, east, or west? Or any of those. So which direction is it going in? So that's why we include the direction. Moving on. So we have case 1 in which vectors are parallel and go in the same direction. So case 1, vectors are parallel and go in the same direction. I'll give you a minute to write all of this down. You can pause the video and go ahead. Alright, so now we're back. And let's calculate this resultant. So I have vector A and I have vector B. So I see A here is worth 4 meters and it is going in the direction of east. North, south, east, west. It is going east. I also see that vector B is going in east. They're going in the east direction. So I have vector B is going 6 meters in the east direction. And this is the resultant that we're finding. So when you see calculate the resultant, this is the resultant that we are finding. this is what we are calculating. So I have a mathematical equation here. I have the resultant equals vector A plus vector B. I have the resultant equals 4 meters east plus 6 meters east. So I just add those two together and I get 10 meters east. So then we have our answer, and then we have our therefore statement. So we have case number 2, in which vectors are parallel but opposite in direction. Vectors are parallel but opposite in direction. Opposite in direction, but parallel. I'll give you a minute to write everything down, and then we'll continue. Okay. So I have vector A. A is going 4 meters in the east direction. It's going in the east direction. And then I have vector B. B is going 6 meters in the west direction. So going in the west direction. So what do we do about these two vectors? Well, if we're adding them, we're finding this resultant right here. This small little arrow is the resultant that we are calculating. So we have vector B, which is 6 meters west. And then we have vector A going 4 meters east. And then we have our resultant, so let's calculate. Up here, I would go resultant equals negative A plus. So that's what I would put up here. But we have 4 meters east plus 6 meters west, and then I'm inverting the direction, so it's actually negative 4 meters west plus 6 meters west, and then I am left with 2 meters west. And that's our answer right there. Because this is going east, it is now negative 4 meters west. We changed the direction. So it is now negative . Okay. Alright. Moving on. So we have case number 3, in which vectors are perpendicular, which means it creates a 90-degree angle. Okay, I'll give you a minute to write all of this down. Okay, let's begin. So we have vector A, which is 4 meters north. And then we have vector B, which is 6 meters east. They create a 90-degree angle, so we're going to use things like the Pythagorean theorem and SOHCAHTOA. The Pythagorean theorem to calculate our resultant, and then SOHCAHTOA to calculate the direction of the resultant. Just so you know. Okay, so first things first is I drew vector A, which was 4 meters north, which means it's going up vertically. It's going up vertically, not down, because north is up. As you can see, I draw a little compass over here. So we're going to do an arrow that's going up worth 4 meters. You can do 4 little squares if you're using graph paper, or you can just draw however much you feel like it. If you want to do it to scale, you can use a ruler if you're using ruled paper, and that'll be that. And then we have vector B, which is 6 meters east, going in the east direction. So I did 6 squares worth, and then it's going in the east direction, so I was drawing it in this direction. So now we have those 2 arrows, and then we're going to draw the resultant. So I'm going to connect it from vector A to the tail, to the head of the arrow. So from this point, I'm going to draw the resultant, and it's going to connect to vector B. And then the resultant is right there. Like, that's the resultant. That is what we are calculating with the Pythagorean theorem. And then we're going to find this angle in here, and that's the direction of the resultant. That's the direction of the resultant. That little symbol right there just means angle. As you can see that right there too. So this is north, this is north, this is east. So it's going to be somewhere in the northeast. It's going to be in the northeast. That's the direction of the resultant. It's going up here is north, east, north, south, west. It's going to be going this way, so it's going to be in the northeast. Okay, moving on. So as you can see here, this looks a little like Pythagorean theorem. Everything is squared. This would be our A, this would be our B, and this would be our C. But I inputted the magnitude, so meters, and I inputted the direction as well. As you can see, everything is squared, and we have a resultant. So if you just want to write over this C squared equals A squared plus B squared first, that's cool. And then you can do this mathematical equation in which you input each vector and the value, the units, and the direction. So the value, the units, and the direction. But then you can drop all that once you get to here. So we have the resultant squared equals 4 squared plus 6 squared. And then we have the resultant squared equals 16 plus 36. And then it equals 52. But we take the square root of the resultant because we want just the resultant, not the resultant squared. And then we square root both sides. And our result was 52 from this addition equals 52. So we took the square root of both sides. So the square root of 52 equals the resultant, which is 7.2111. Wait, 1, 2, 3, 4. Yeah, okay, so the resultant equals 7.2111 meters. So that's our value for the resultant there. And we're not done yet. So we found the resultant. We calculated the resultant. We found what it was worth. It was worth 7.2111 meters. And now we need to find the direction of the resultant. And do you remember when I said it was going to be in the northeast area? Direction of the resultant. In order to do that, we use SOHCAHTOA. So just to review, sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and then tan equals opposite over adjacent. This is the hypotenuse. This is the adjacent. And this is opposite. Because we're calculating this angle here. So the adjacent would be the line connecting to the angle. We have our hypotenuse, which is the longest side, and then we have the opposite from the angle would be this side as well. So what we have is we have A and B given, and we calculated the hypotenuse, we calculated the resultant, and it was worth that much. But we're going to be using vectors A and B to calculate the direction. The direction of the resultant. So, we have opposite and adjacent. And that's opposite and adjacent would be tan. So we're going to be using the tan function. And that's what we did here. So we have tan theta equals 6 over 4. So it was opposite over adjacent. So we did theta equals tan of the inverse function, not tan, the inverse function of tan. That's why there's that -1 there. And we got 56.3099. And then when we put it into our final answer, we're just going to round up to the nearest degree. So for our final answer, the resultant equals 7.2111 meters, north 56 degrees east, or 0.056 degrees. So that would be our answer. That was a lot, so I know it seems complicated at first, but perpendicular vectors are easier than vectors that make an angle. That's going to be our fourth case, is that vectors that make an angle. So let's begin. Let's move on to the next case. I know that was a lot, so if you want to take a minute and pause the video, just to review it and review the notes. If you want to listen to it again, if you want to watch the part again, if it was overwhelming for you, you can. And we're going to be doing more problems like this in the future, so don't worry if you don't get it quite yet. And moving on to case number 4. So this is case number 4, in which vectors make an angle. Let me do that better. Case number 4, vectors make an angle. What the heck is going on here? I know it seems complicated because this diagram looks complicated. There's numbers all over the place. But it's actually very simple. We're just going to use some very simple trigonometry to help us figure out this vector question in which the vectors make an angle. We're going to try and figure this out together. So let's begin. So as you can see here, we have vector A, which is 4 meters north 60 degrees east. And then we have vector B, which is just 6 meters east. So first things first is we made our northeast sign. And it's a dotted line going to north, south, and west, and east. So that's first things first. That's what you want to do. And then from the northeast southwest compass, we're gonna make a line that goes 4 meters 60 degrees from the north line. So this line here is going to be 60 degrees. Does that make sense? Hopefully it does. So we've made that line right here, 60 degrees. It's north 60 degrees east, meaning 60 degrees from the northeast line. Okay. And then we have 6 meters just going east, so it's a straight line. Going east, so 6 meters east. And then what we did was we connected vectors A and B, and we created our resultant. That's what we did. So this line here is our resultant. So this right here is a 90-degree angle. So we have this triangle, right? And then going up, this was a straight line. Straight line totally is 180 degrees. This right here, perpendicular, so 90 degrees. We have 60 degrees right here. So 180 minus 90 minus 60 equals 30 degrees. And that's how we got the angle right there. So this angle right here. Straight line, 180 degrees, 90 degrees, 60 degrees. 180 is the total number of degrees in one triangle. So minus 90 minus 60 equals 30 degrees. Okay, so we had this angle, we have this angle, we have this angle, and then we have 180 minus 30 degrees equals 150. And that's how we got this angle right here. We got 150. So what we're looking for is this angle right here. And we're going to add it to this angle because what we're looking for is this angle. We're looking for this angle right here. We have this angle. So this one, question mark, this one, and then this one is what we're looking for. For the direction of the resultant. So what we're looking for is the entirety of that angle from the north line to the resultant line. So that's what we're looking for when we talk about the direction of the resultant. And again, I think it's going to be somewhere in the northeast area, hopefully. Okay. So the formulas we'll need is cosine law, and then the angle cosine law. 1, 2, that's what we're going to need to solve these questions. Okay. So calculate the resultant. So we're going to go down here. C squared. So C squared equals A squared plus B squared minus 2AB cos C. And that's the resultant squared. And then we're going to go to down here, the resultant squared, and then we're going to plug in the numbers. 6, 4, and we have cos 150. So we have the angle that's across from the hypotenuse. Well, not the hypotenuse, but the longest side, or the resultant, across from the resultant. And we're looking for the resultant. We have that angle, and that's a good thing because we need that angle for the formula in which we will find the resultant. So we have the resultant squared. We've plugged in all the numbers. And then we got a big old number. And And we're going to square both sides because it's the resultant squared, and we're looking for just the resultant. And we're not looking for the resultant squared, we're looking for just the resultant. So we get a big old number, square both sides, and then we are left with 9.6731 meters, and that's the magnitude and the value of our vector, or resultant. Okay, moving on. So now we're looking for this angle. So we have this formula here. It's cos theta b squared plus c squared minus a squared over 2bc. So b okay. So A goes directly across to that A there. B goes directly across to this B here. C goes directly across to this C here. And that's how you know which numbers to plug in where. So this angle corresponds with this side. This angle corresponds to this side. And this angle corresponds to that side. So B, right there. C, right there. And then A, right there. And then we have 2BC, that's just on the bottom. So we figured out the top, we figured out the bottom, and then there are two large numbers in there, and we'll leave them in there. So we have theta, we need to move cos to the other side, so it becomes the inverse function. And that's why it has that little -1 right there. So we have theta equals cos, inverse cos, 73.5689 over 77.3848. And we have this big old angle right there. But it doesn't end there, because the actual direction of the angle is this angle right here. We're looking for this angle right there. So that's the actual direction of the vector, or the resultant. So what we did was we added this angle, and then we added this angle, and then we got this number. 60 plus 18.0681 equals 78.0681. We added this angle and this angle, we added them together. Okay, so we got that angle, and that's our final angle. And we have our resultant with the magnitude, and then the direction. Remember, we just round to the nearest angle, or 0.78, or 0.78. And that's our answer. Alright. That was everything for today. Hope you found that helpful. In the next episode, we're going to be doing these questions start from finish. And I hope you found this very helpful, and I hope you have a very good day.